So the main objective of our project is to develop a material handling system by integrating various sensors and actuation using Raspberry Pi microcontroller. The objective of our project is to integrate the sensors and the actuation system using our Raspberry Pi. So I'm going to use the system. So this is the PLC. This is the proximity sensor. This is the conveyor belt. This is the single and double acting cylinder, and also our Raspberry Pi.
This is a design of our board. We take inspiration for our board by industrial process of board, where they use pneumatic actuators to load the board into the box. So the concept is same with our project. So we take the inspiration of the golf board. As you can see from our design, we have plastic cover as a window so that we can observe what's going on the inside. From the inside, as you can see that we have slider. We build slider from the cardboard. To make sure the ball slide through into the box smoothly. On the top of our box, we have metal plate to ensure the proximity sensor to send the metal so it can release the ball into the box. At the same time, automatically sense the metal plate. For the whole body, we use leftover cardboard. I think this.
Now I'm going to demonstrate our wiring for our project.
Now, as we can see from the wiring diagram, the 24-volt AC is connected to PLC. Another two jumper wires are connected to the 24-volt DC output of the PLC, and these two wires are connected to the live wires of relay A and relay B, which in the diagram are stated as L relay and R relay respectively, with resistors that is situated between the conveyor belt. GPIO 5, 6, 14, 15, 17, 22, 23, 24, 25 and 27 are identified. GPIO 17 and 27 are connected to left and right sensor respectively. Power source for the relays and sensor are obtained from the 24-volt DC from PLC through a series 4.7k ohm and 2.2k ohm resistors to reduce its voltage. GPIO 22 and 25 are connected to relay A and B respectively. Since signals are required as an input to the Raspberry Pi, red and black switches are included. GPIO 5 and 6 are connected to red and black switches respectively. Once again, the live wires are connected to the power source from PLC that is being lowered by resistors. 4 single-acting pneumatic cylinders with solenoid valves are connected to the pressurized gas. The conveyor belt moves from the left to right. The top left cylinder is connected to GPIO 15. The bottom left cylinder is connected to GPIO 14. For the right side, which lies the second sensor, the bottom right cylinder is connected to GPIO 23, while the top right cylinder is connected to the GPIO 24. The live wires of the solenoid valve are connected to the same power sources as other connections, and it is connected to the right and terminal of a PNP transistor. The output terminals of the GPIO are connected to left and terminal of the PNP transistors. Thereafter, a wire is linked from the center terminal of the PNP transistor to the black wire of the solenoid valve. And for humidity and temperature sensor that we will mention as DHT22 is connected to GPIO 4.
Coding for this whole project, how we ran our pneumatic actuators using our Raspberry Pi microcontroller. So let's have a look at the coding.
Okay, so now let's have a look at our coding here. First of all, we imported all our libraries, including our GPIO Then we imported sys from exit, and also sleep from time. Then we imported our humidity sensor. After doing so, we reassigned the name of our humidity sensor, and we assigned each of our GPIOs the name of the sensor to ease our flow in the coding. Moving on, we set up all our GPIOs as inputs and outputs, and also we did the coding to measure the temperature and humidity of the surrounding. Next, we move to our coding. So now, based on our coding here, we have one red button and one black button. So if either of them are pressed, our relay turns on and it moves to the right. And our bottom left piston and our top left pistons are actuated. Same is our bottom right piston and our top right pistons. Then our balls are loaded into the holder. Next, we have all these lines here. So when our proximity sensor, the first proximity sensor is triggered, we will have all this coding to run. That is, we stop our conveyor, and then we have our top left piston to retract and extract back, followed by our bottom left piston to retract and extract back. This causes one ball to drop through. So following this, we have 3 consecutive sets of these. After 3 balls drop in, the conveyor starts to move again, and our coding prints 3 balls in the box. Following that, once our second proximity sensor is triggered, the conveyor belt stops, and the same thing happens on the right hand side. That is, the top right piston retracts and extracts back, and the bottom right piston retracts and extracts back. This causes one ball to drop through. So is the same one. We have 3 sets of this coding, so 3 balls drop through. Once 3 balls drop through, we have our conveyor belt moving again. This would print out 6 balls in the box. And then we will have our conveyor belts moving to the left again. So in this we will have our initial proximity sensor being triggered, causing the top left piston to retract and extract back, and the bottom left piston to retract and extract back, causing 1 ball to drop, and we will have 2 balls to drop in this session, resulting in 8 balls in the box. So that is all for the coding right now.